Hi, I'm Keenan Casey for TouchPlus.com. In this lesson, we're going to be looking at TCP, the Transmission Control Protocol. TCP is one of the most important protocols on the internet. In contrast to UDP, TCP is very much a heavyweight protocol. It provides a lot of services, but it requires a lot of overhead to do so. TCP is reliable. It provides a connection abstraction. It's safe, meaning that a fast sender will be prevented from overwhelming the receiver or the network capacity. And lastly, it's performant. Since it is so important, since it's so widely used, TCP makes great efforts to be efficient in the way it carries out its communication. TCP might be compared to a freight train. It's a lot of work to get it moving. It requires a lot of setup to create a connection, that is, building tracks. However, once the connection is created, it's very reliable and it's great at moving a lot of data between two locations. Let's look at an example of how TCP operates. TCP, because it is connection-oriented, has to first set up a connection between the client and the server. A connection request will be sent to the server, and an accept connection message will be sent back to the client. At this point, the connection, we can imagine this pipe between the client and the server, is set up. When data needs to be sent in either direction, a TCP data segment can be sent, either from the client to the server or from the server to the client. When this connection is complete, a disconnect request will be sent from the client to the server. A disconnect response will be sent back in return. One thing to note about this is everything that's in that yellow pipe, that connection between the client and the server, is reliably and safely sent. By reliably sent, I mean if you send it, you can expect it to be delivered. Now, that may take multiple retransmissions, but TCP is going to get the segment there. It's safe in the sense that error control and congestion control are provided. Notice in this set of tables that TCP provides all the transport layer services that we discussed in the introduction lesson. It provides multiplexing, it provides error control, reliability, the connection abstraction, as well as flow control and congestion control. So from the list of services that we talked about, TCP does it all. This is the structure of a TCP segment. Notice we've got a 32-bit width. We begin with a 16-bit source port number and a 16-bit destination port number. These two numbers are basically addresses for the processes at the sender and receiver. Next, there is a 32-bit sequence number and acknowledgement number. These two numbers are used to sequence the bytes in the data stream exchanged between the two communicating hosts. And these two numbers are used to implement duplicate detection and to order the packets. Next, there's some flags. There's a 16-bit receive window, which is used to implement the flow control algorithm to prevent the receiver from being overwhelmed by a fast sender. Next, there's the checksum. This is the same as UDP. It's a specially computed number that represents the state of this segment. It implements the error control so that the receiver can identify corrupted segments. The checksum algorithm is pretty easy to understand. It basically treats the entire segment, data and header, as a sequence of 16-bit integers. Those integers are then added up, wrapping when necessary, and when the sum is computed, it's negated. So we've got the opposite of the sum of all the 16-bit integers in this packet. Because of the way this is computed, if all of the 16-bit integers are summed up at the receiver, they should equal 0. And if they don't equal 0, then the packet was corrupted. The urgent data pointer is rarely used, and the options field may specify a number of low-level details of TCP. Finally, at the bottom is the application layer data, the payload of the packet, the data that we're actually trying to send. TCP has a number of very useful properties, and it's used all the time in a lot of protocols. TCP provides a reliable, in-order stream of bytes. That stream of bytes is actually full duplex. It goes in both directions, and it is flow controlled and congestion controlled. TCP, as we said, is a heavyweight protocol. It requires a lot of overhead, but it provides a lot of services. Here are some examples of protocols that use TCP. It's really any protocol that needs reliability. HTTP, FTP, SMTP. as well as remote desktop, remote login kinds of protocols like Telnet and SSH. This is just a sampling of the many protocols that are implemented using TCP. This has been an introduction to TCP. We've been in the transport layer. In subsequent lessons, we'll look at some of the specifics of how TCP is implemented. I'm Keenan Casey for TutsPlus.com. Thanks for watching.